Right now, in laboratories funded by hundreds of millions of dollars, researchers are pulling DNA from frozen bodies that have been dead for tens of thousands of years. And they are bringing them back. Not in theory, not in concept. One of them is already alive. These are 5 Ice Age animals that scientists are actively trying to resurrect. And the implications are bigger than most people are ready for. Number 5. The cave lion. In 2015, mammoth tusk hunters working along the Uyandina River in northeastern Siberia found something that stopped them cold. 2 lion cubs, frozen in permafrost, so perfectly preserved that their fur was still intact. Their whiskers were still in place. Their paws were still soft. They looked like they had fallen asleep the previous week. They had been frozen for approximately 12,000 years. Then in 2017 and 2018, 2 more cubs were found nearby. Boris and Sparta, a male and a female. Boris was 43,500 years old. Sparta was 28,000 years old. They were found within a few hundred meters of each other, separated by 15,000 years of time, preserved in the same frozen riverbank as if the ice had been waiting to give them back. CT scans revealed everything. Their organs were intact. Their brains were preserved. Their muscle tissue was still present. Scientists could see exactly how they had died. Both cubs were between 1 and 2 months old, likely lost or separated from their mother, dead from exposure rather than predation or disease. They had never been sick. They had never been injured. They were simply frozen at the very beginning of their lives and held there, perfectly, for tens of thousands of years. The cave lion, Panthera spelaea, was the largest lion that ever lived. It was 12% larger than the biggest modern African lion. It ranged across Europe, Asia, and into North America. It appears in Paleolithic cave paintings across France and Spain, drawn by humans who lived alongside it, who feared it, who painted it with a detail and accuracy that suggests they studied it closely. It was not a distant mythological creature. It was a neighbor, a predator that shared territory with early humans for thousands of years. It went extinct around 13,000 years ago. Climate change, the collapse of the megafauna it hunted, the same cascade of events that ended the Ice Age world. But Boris and Sparta changed the conversation. The DNA extracted from their tissue is among the highest quality ancient DNA ever recovered. Scientists have sequenced significant portions of the cave lion genome. They have identified the genetic differences between cave lions and modern lions, the adaptations for cold, the size differences, the physiological traits that made it the apex predator of the Ice Age. The closest living relative is the modern lion. The genetic distance is close enough that researchers believe the same approach being used for the woolly mammoth, editing the genome of a living relative to reintroduce extinct traits, could work for the cave lion. No company has publicly announced a cave lion de-extinction project yet, but the specimens exist, the DNA exists, the technology exists, and in the world of de-extinction, those 3 things together have a way of becoming an announcement. Boris and Sparta have been frozen for tens of thousands of years. They may not stay extinct much longer. Number 4. The woolly rhinoceros. In 2014, in the Yakutia region of northeastern Siberia, a mammoth tusk hunter named Alexander Bandarov found something protruding from a riverbank. He thought it was a mammoth. It wasn't. It was a woolly rhinoceros calf, 7 months old at the time of death, preserved so completely that its fur was still attached. Its skin was intact. Its internal organs were present. Scientists named it Sasha. It was the best preserved woolly rhinoceros ever found. Then, a few years later, another specimen was found nearby, a juvenile, 3 to 4 years old, even more intact than Sasha. Limbs preserved, organs preserved, intestinal contents preserved, meaning scientists could determine exactly what it had been eating in the days before it died, tens of thousands of years ago. The woolly rhinoceros, Quelodonta antiquitatis, was one of the most formidable animals of the Ice Age. It stood 6 feet tall at the shoulder. It weighed up to 3 tons. Its 2 horns, the front one reaching up to 5 feet in length, were not just weapons, they were tools. Scientists believe woolly rhinos used their massive front horn to sweep snow aside to reach the vegetation buried beneath, the same way modern musk oxen use their heads to clear feeding areas in winter. It was covered in thick, reddish-brown fur. It had a massive hump of fat and muscle over its shoulders for energy storage during the long Arctic winters. It was built for cold in a way that modern rhinos, all of which live in tropical and subtropical environments, are not. It went extinct around 14,000 years ago. Climate change again. The warming that ended the Ice Age transformed the cold steppe grasslands the woolly rhino depended on into forests and wetlands. The vegetation it had evolved to eat disappeared. The rhino followed. From Sasha and the juvenile specimen, scientists have extracted high-quality ancient DNA. The woolly rhinoceros genome has been substantially reconstructed. Researchers have identified the specific genetic adaptations that allowed it to survive in Arctic conditions. The fur, the fat storage, the cold-adapted metabolism. The challenge is the living relative. Modern rhinos are not closely related to each other in the way that Asian elephants are related to mammoths. The 5 surviving rhino species diverged from each other tens of millions of years ago. Finding the right genetic platform for woolly rhino revival is more complex than the Mammoth Project. But the specimens are extraordinary. Sasha's fur has been analyzed in detail. The pigmentation genes have been identified. The cold adaptation genes have been mapped. Every year, the permafrost gives up new specimens, each one more intact than the last, each one adding more data to a genome that is slowly, piece by piece, being reconstructed from the ice. The woolly rhinoceros has been frozen for 14,000 years. The scientists working on its genome are getting closer every year. And the permafrost of Siberia still holds thousands of specimens that haven't been found yet. The ice is melting. The bodies are emerging. And every body that emerges brings the woolly rhinoceros one step closer to walking the earth again. Number 3. The Tasmanian tiger. On September 7th, 1936, the last known Tasmanian tiger died alone in a cage at Hobart Zoo in Tasmania. Her name was unknown. She had been captured from the wild and placed in an enclosure that offered no shelter from the cold. On the night she died, the temperature dropped. The zoo had closed for the day. Nobody came to check on her. She died of exposure, alone, in a cage, 59 days after the Australian government had finally granted her species legal protection. The Tasmanian tiger, the thylacine, was not a tiger. It was a marsupial, the largest carnivorous marsupial of the modern era. It had the body of a large dog, the stripes of a tiger across its lower back, and a jaw that could open to an angle of 80 degrees, wider than any placental carnivore alive today. It was the apex predator of Tasmania for thousands of years. European settlers killed it systematically. Farmers blamed it for sheep deaths. The Tasmanian government paid a bounty for every thylacine killed, 2 pounds per adult, 1 pound per pup. Between 1888 and 1909, over 2,000 were killed for the bounty alone. Hunting continued after the bounty ended. By the time protection came, it was 59 days too late. The thylacine was declared extinct in 1986. But the story didn't end there. In 2017, researchers at the University of Melbourne began the most ambitious de-extinction project ever attempted for an Australian species. They sequenced the thylacine genome from museum specimens, including a 130-year-old preserved pup in Sweden and a 110-year-old preserved head in a Melbourne museum. In 2023, they published the most complete genome ever assembled for any extinct animal. 99.9% accuracy, chromosome-level assembly, including the centromeres and telomeres, the hardest regions to reconstruct. But Colossal Biosciences went further. They extracted RNA, not just DNA, from the preserved specimens. RNA carries information about gene expression. It tells scientists not just what genes an animal had, but which genes were active in which tissues, at what times, in what combinations. From the preserved head, they extracted RNA from the brain, the eyes, the tongue, the nasal cavity. They began reconstructing not just the thylacine's genome, but its biology. how it smelled, how it saw, how its brain was organized. The living platform is the fat-tailed dunnart, a small marsupial that is the thylacines' closest living relative. Scientists have already successfully edited dunnart cells to express thylacine traits. The next step is producing a viable embryo. Colossal Biosciences has set a target of 2028 for the first thylacine-like animals. The last one died alone in a cage in 1936. In less than a decade, its descendants may be walking the Tasmanian wilderness again. Some extinctions, it turns out, are not permanent. They are just very long pauses. Number 2, the woolly mammoth. This is the one that started everything. In 2021, a company called Colossal Biosciences launched with a single stated mission: bring back the woolly mammoth. They raised $15 million on day one. By 2023, total funding had exceeded $225 million. The investors included some of the most serious names in science and technology. The scientific team included geneticists from Harvard, paleontologists from leading universities, and reproductive biologists who had spent careers developing assisted reproduction techniques for endangered elephants. This was not a fringe project. This was the most well-funded de-extinction effort in human history. The woolly mammoth, Mammuthus primigenius, needs no introduction. It stood 11 feet tall at the shoulder. It weighed up to 6 tons. Its curved tusks reached 15 feet in length. It was covered in thick layers of fur and fat that allowed it to survive in temperatures that would kill a modern elephant in hours. It roamed across Siberia, Europe, and North America for hundreds of thousands of years. It went extinct in 2 waves. The mainland population disappeared around 10,000 years ago. Climate change, habitat loss, human hunting. But a small island population survived on Wrangel Island in the Arctic Ocean until just 4,000 years ago. The pyramids of Egypt were already ancient when the last island mammoths died. The permafrost of Siberia has preserved mammoth specimens in extraordinary condition. Entire bodies, intact fur, preserved stomach contents. In some cases, liquid blood has been found in frozen tissue, blood that had remained liquid for tens of thousands of years due to the unique antifreeze properties of mammoth hemoglobin. Scientists have sequenced the complete mammoth genome multiple times from multiple specimens. They know exactly what made a mammoth a mammoth. The living platform is the Asian elephant, the mammoth's closest living relative, sharing 99.6% of its DNA. The genetic distance between a mammoth and an Asian elephant is smaller than the genetic distance between a chimpanzee and a human. Colossal's approach is not cloning. It is genome editing. They are taking Asian elephant cells and editing them, using CRISPR technology to reintroduce the mammoth-specific traits: the cold-adapted hemoglobin, the thick fur, the fat storage, the cold-resistant metabolism. The result will not be a pure mammoth. It will be a mammoth-elephant hybrid, an animal that looks, behaves, and functions like a mammoth, capable of surviving in the Siberian cold. In 2025, Colossal demonstrated proof of concept by producing woolly mice. Mice engineered with mammoth fur genes that grew thick, mammoth-like coats. The technology works. The editing works. The traits transfer. The target is 2028 for the first calves. But here's what makes the Mammoth Project bigger than just one animal. Scientists believe that reintroducing mammoths to the Siberian tundra could help slow climate change. The theory, called Pleistocene Park, argues that large grazing animals compact snow in winter, allowing cold air to penetrate the soil and keep the permafrost frozen. Without large grazers, the snow insulates the ground, the permafrost warms, and the vast stores of carbon locked in Siberian permafrost are released into the atmosphere. The mammoth isn't just an ice age animal. It may be a climate tool, a living, breathing, tusk-bearing solution to one of the most urgent problems on Earth. The last mammoth died 4,000 years ago on a frozen island in the Arctic. By 2028, its descendants may be walking the Siberian tundra again, compacting snow, keeping the permafrost frozen, doing the job they were built to do. Some animals don't just deserve to come back. They need to. Number 1. The dire wolf. In February 2025, Colossal Biosciences made an announcement that stopped the scientific world. They had brought back the dire wolf. Not a reconstruction, not a fossil, not a computer model. 3 living animals, 2 males named Romulus and Remus, and a female named Khaleesi, born in a secure facility in the United States, carrying the genetic signature of Enochion dirus, the dire wolf, an apex predator that went extinct 9,500 years ago. The announcement was met with equal parts awe and controversy. Scientists debated the methodology. Ethicists raised questions about the implications. The internet exploded. But the animals were real. They were alive, and they were the first de-extinct megafauna in human history. The dire wolf was not simply a large wolf. It was a separate species, more closely related to African jackals than to modern gray wolves, despite its appearance. It was 25% heavier than the largest modern gray wolf. Its skull was broader. Its teeth were more robust, built for crushing bone rather than simply cutting flesh. It was the dominant large predator of North America for hundreds of thousands of years, hunting alongside saber-toothed cats and short-faced bears in a megafauna ecosystem that no longer exists. It went extinct at the end of the Pleistocene, the same cascade of events that took the mammoth, the saber-toothed cat, the giant ground sloth. The prey disappeared. The predator followed. The La Brea tar pits in Los Angeles have yielded over 4,000 dire wolf specimens, more than any other large mammal at the site. They are the most common large predator in the fossil record of North America. They were everywhere. And then they were gone. Colossal's approach used ancient DNA extracted from dire wolf fossils to identify the key genetic differences between dire wolves and their closest living relatives. They then edited the genome of gray wolves, introducing 20 specific genetic changes to produce animals that carry the defining traits of the dire wolf. The broader skull, the bone-crushing dentition, the larger body mass, the coat coloration. Romulus, Remus, and Khaleesi are not pure dire wolves. They are gray wolves carrying dire wolf traits, the same hybrid approach used for the Mammoth Project. But they are alive. They are healthy. They are the proof that the approach works. And here is what that means. If the dire wolf can be brought back, an animal extinct for 9,500 years, from DNA extracted from fossils, then the question of which extinct animals can be revived is no longer a question of possibility. It is a question of priority, of funding, of time. The mammoth is coming by 2028. The thylacine is coming by 2028. The dire wolf is already here. The Ice Age ended 11,700 years ago. The animals it took with it are starting to come back. One genome at a time, one edited cell at a time, one living, breathing animal at a time. The scientists working on these projects are not playing God. They are correcting a record, reversing extinctions that happened too fast, too recently, for the planet to adapt to their absence. Returning animals to ecosystems that still need them, filling gaps in food chains that have been broken for thousands of years. The permafrost is still giving up bodies. The DNA is still intact. The technology is advancing faster than anyone predicted 5 years ago. The Ice Age is not over. It is just beginning again. And this time, the animals are coming back with us. Extinction just got an expiration date. We'll see you in the next one.